All right, 7-8, addition, subtraction, expressions with fractions found on page 236, and all our problems over here are on 237. We have done this lesson before, at least the addition and subtraction and expressions. I know we've done it at least a few times. Here it is back in 4-3 when we did it, where it tells us what n is. We just plugged it in. We were combining like terms. I know we've done it more than that too. Done it somewhere over here. Multiplying and dividing ones over here. Sure we did adding. Probably what, in chapter 2? 1 somewhere. Negative values. Is that chapter 5? We did it over here. Oh, there they are. Expressions with integers. There's some adding and those are right. There's some adding and subtracting. So we did in chapter 5. We did 4-3 was this. 5-8 was this lesson. Probably did it in chapter 6 somewhere too. I don't know. I'd have to look around. But all that's changing here this time is now we're doing what we've done with fractions. That's the only difference. So number 1. Looking at page 237, it says 5 1/2 plus n. And then it says when n equals 3 1/4. So officially we're not solving anything today because there's no equal sign in any of these. Remember, an expression is the representation. There's any equations composed of two expressions, whatever's on the left side of the equal sign, whatever's on the right side of the equal sign. Those two expressions are equivalent. They should equal. Otherwise, that's what the equal sign means. They have the same values on both sides. When you combine everything, do whatever. So today here, again, it's not officially solving, but for all practical purposes, that's kind of what we're doing. The mathematical word they use is to evaluate these or to simplify these. Just words, to be honest with you. So what do we do? How do we go about taking care of this here? So 5 1/2 plus n. And then a little later on here, it tells me what n is. N equals 3 1/4. What do I need to do? I need to plug that value in for n. So I have 5 1/2 plus n, but not n, because n is 3 1/4. So first move here, just plug in the value for the variable, and then go ahead and solve 5 1/2 plus 3 1/4 as you would. Perhaps you can do it mentally. But if not, you can rewrite with that common denominator, which is 4. Add the fractions. 2/4 and 1/4 is 3/4. 5 and 3 is 8. There it is. 5 1/2 plus n, when n is 3 1/4, simplifies or just turns into 8 3/4. Pick it up. Throw it in the garbage. Okay. Try number 3. 1 1/6 plus, I'm not going to write r, I'm going to call it v, plus 1 2/5 when r equals 1 3/4. Or I'm sorry, when v. 1 1/6 plus v plus 1 2/5 when v is 1 3/4. This one is not well set up for a mental math shortcut. Most likely you're just going to have to grind this one. Not that it's going to be impossible, but if you're trying to shortcut this one, it's just not a good one to try. So, again, first thing, somehow, some way, we need to plug in the numerical value for v into this here. And we're going to be adding three values together. I'd probably just rewrite them, all three of them. And personally, I think finding a common denominator for all three is faster than doing it as two standalone problems. But common denominator between 4, 5, and 6 is 60.
Oh, what? I did 120, but it works. Yeah.
Yep, that's fine if you multiply, but the least common denominator is 60. And if you got 120, you're still in the game because that's a common multiple. You'll just be slightly bigger numbers, and you will definitely have to simplify. But so write your equivalent fractions. A 10 times 15, 45 times 12, 24. If you had 120, you'd be at times 20 times 30 times 24. That's what it looked like if you had 120. But go ahead and add. 10 and 45 is 55. 55 and 24 is 79 over 60. 1, 2, 3. 3 and 79 over 60. Simplify that. 4 and 19 over 60. Over here you would have had 158 over 120. Which would turn into 38 over 120, which would then turn into 19 over 60. With the 4, of course. 79 over 60 with 60, 158 over 120 with 120. Simplified. This one's all done. This one needs to be simplified again, divide by 2 to get to your 19 over 60. So, but for 19 over 60 is what we get. Okay. Try number 5. 9 and 1/6 plus 5/6 minus m, when m is 1/2. So this one does indeed have a shortcut, if you decided to use it. And again, this one could be a mental math problem for you. But the 5, 6, and 1/6 equals 1. 1 plus 9 is 10. Minus 1/2. 9 minus 0, 2/2 minus 1/2. 9 and 1/2. And again, your move would be to combine these, make your whole fraction, add it to 9. You got 10 minus 1/2. 9 minus 0, 2/2 minus 1/2, 9 and 1/2. All right. Try number 8.
Okay.
5 plus 3 and 3/8 plus d plus 2 and 5/8. And this time when d equals 1/6 and 1/6. 5 plus 3 and 3/8 plus d plus 2 and 5/8 when d equals 6 and 1/6. writing going down in here.
Yeah. I had to.
What should I do first?
Common denominator. Rewrite it. Just common denominator.
I really didn't want to interrupt. How are you
I
guys?
can interrupt here. Oh, yes. There we go.
You might want that.
Whoop, whoop. Thanks, Jen.
No problem. Thank you.
All right, anybody, where do I want to start? There's only
Me.
one real spot I should start.
The common
No.
denominator. Wait, no, you add 3 3/8 and
Right.
2 and
I should, this is where I should start. Because 3/8 plus 5/8 is,
1.
and now what do I add?
The whole numbers.
Which is, I'm adding what?
3, 2, and 6.
Not 6. 5, 3, 2, and 1. I got a 5 here, a 3, a 2, and then these combine together to make a whole. What's 5 plus 3 plus 2 plus 1? 11. And now what do I do with my 11?
Add
6 and 1 6, which equals
17 and 1 6.
17 and 1 6. It is the answer.
Same. I didn't do it that way.
But see how easy it was? I combine these together to get my whole fraction. 5 plus 3 plus 1 plus 2 is 11. 11 plus 6 is 17. The 1 6 just comes with. There's no fractional part left. I don't have to common denominator or anything here. I mean, yeah, you can set it all up. Common denominator is 24, 3/8 and 5/8 and 1 6 with the denominator 24, but you should come back to this here. But this is, again, if you get it, cool. If not, it's okay. All right, last part here, more or less the same stuff here. Again, they're kind of continuing what we did in 7-7 here. Most of these have a built-in shortcut to them. Not all, most. So see what you can do, what you can find. I'll pull a few sticks out here. Number 9. Again, I'll be curious to know if you found the shortcut. If you didn't, that's okay. But if you did, I would love to hear about what you saw and how you did it. Number 13.
Oh,
15. And 17. All right, go with those 4. 9, 13, 15, and 17. Ultimately, the correct answer is what matters here, but I'll be interested to know how you solved them.
Possibly.
That's good. I left the room with last time you guys. Tears of happiness.
Hope you're not too bummed out. I skipped over 11.
Why?
I wanted 11.
Why?
0 plus 11 and 2 kids.
11 and 12 just felt a little. I thought we
Oh, I
could just
like
skip
12
that
too.
part. The old adding by 0 badge.
I got these.
You can do those on your own. Hopefully you can solve them mentally too. 11 and 12. That'd be awesome.
We get it.
These are the last 4 we'll do. Move on with our day. So I guess one more time for Sig if he's out there. Right. Very good. Tomorrow, mainly for you, Sig, if you're listening out there, we'll check this homework tomorrow. Do our last lesson of the chapter, 7-9 tomorrow. Friday, we have a quiz on 7-7, 7-8, 7-9. We'll do the quiz, and then we're going to do lesson 7-10, working backwards, one of those word problem-esque, slightly advanced lesson type concepts with you guys. Should be a fun one. Working backwards is one of my favorite things to teach and go through, so it's kind of cool. Always doing the opposite of everything, getting back to the beginning. You know where you ended, where did you start? You got to undo and go backwards on everything, so that's the fun of it. It's like reversing everything in your mind. Reverse order, reverse operations to get back to the start. And then Monday, I passed out the practice test, so we'll check that on Monday. And then next week, Tuesday, we're planning the test. So, Jackson.
Why did we stop doing those competitions where we'd have to solve like all those problems?
We all did really bad. We would all do really bad.
Terrible.
There's reasons, I suppose. I don't want to get through all of them here, but I did enjoy that too very much last year with you
You know
guys.
what happened to
I can't guarantee we won't ever do that
her
again.
hair off?
I know.
Like, almost.
She cut her own.
Okay,
It looks really bad.
Lily.
Yeah. She cut her own hair.
Cut her hair.
So Mrs. Petrangelo, but we're Facebook friends, so she put pictures of all of it up there, and it was like, oh my gosh. Yeah, it's the mullet look has definitely.
Yeah.
I haven't seen her in person, but I was looking at her.
Yeah, I saw the picture.
It's very mullet-y. So. But you know, you're a 4-year-old girl. Who cares, right?
Yeah.
That juncture here. It's not like your nowadays girls and boys and do your hair, wear deodorant and stuff. And, you never know when you'll meet that special someone. You never know. That special someone, Jackson. You don't want to be looking like a, a trash can. Right. Once you're married, then you can let it all go again. I'm exhibit A of that. Just let it go. Right. Will I cut? I'm debating if I'm going to cut my hair again before the start of next year or not. I haven't decided yet.
You should grow your beard out.
Yeah.
I might do
Get
that
like
too.
those
Just,
super long beards.
right. Well, then I get my Jesus complexion going here with the long hair, the long beard, and start just walking around in my sandals around this place. Right.
Borrow one of Father's white, robes.
That's how I used to roll in college. Everybody else would be looking nice, and I'd show up in a white T-shirt and sweatpants and flip-flops to all my classes. Right. Well, I was my own kind of dude in college there, and
Where did you go to
just
college?
kind of Madison for 3 years, and then I
Your brother's going to Madison.
transferred to Stout. Oh, Madison's hard. Madison's really hard. You get there, and you're like, man, I'm smart. I was salutatorian in my class, number 2. Then you get to Madison, and everybody there is like the salutatorian, and they're all like really smart. When I went there were a lot of Asian kids. They work really hard. Like, they have no concept of football games or that's not, they're just all, let's do more homework together. That's what they do.
Your subscribers might be
And then in Madison, everything is graded on the curve. Like, you're in your science class, and there's like 1,000 people in the class, mind you. And in that, of those 1,000 people, it's preset. Only 5% will get an A, 5% will get an A minus, 5% will get a B plus, 10% will get a B, 5%, and it goes all the way down to 5% will get a D minus, and 5% will get an F in this class. So you're always in competition against everybody there too, which, and then you realize how smart all these, and then you see all these dudes like studying all the time. And,
That's not my brother.
whew. Right. Yeah, it's a dog eat dog type of world at Madison, though. Right. But no, if you get like a B in class, you're like, oh my god, this is the greatest accomplishment of my entire life. Here, truth, telling you.
And then there's Asian kids in class.
Yeah.
I don't think my brother's taking like a
They're
solid.
just
I didn't get a lot of A's at Madison. I got a decent number of B's. I got a couple A's and I got some less than B's.
Did you ever get an F?
No. Got one D and then I had to retake it.
What
My
class?
brother had to retake
Some
that.
literature class, something about like cinema and
Sixth.
literature is just the worst of the worst. I couldn't care less about that. Oh my gosh. Analyzing these books from the 1700s and writing out long essays about them.
There's a place in Madison called Sigma.
Just
Sigma,
awful.
Sigma.
Truly terrible work.
Place in
So.
Austria called.
Okay, back on track there. Number 9, Brooke.
Number 9. Okay, so first I added up my 2/5 and 3/5,
Yeah, I like that.
and I got 1. So I added 5 and 3, which is 8, and then I got 9, and then 9 plus 6 is 15, and then I got 15 and 1/4.
Right, and that's that's the good way to solve it. So she found the shortcut first. And again, I mean, without that shortcut, you got to find common denominator between 5 and 4. That's not hard, 20. But then you got to write 3 equivalent fractions. You got to add them. You're going to get 25 over 20. You're going to have to resimplify, rewrite. Impossible? No. Difficult? Probably not either. Does it take more time? Absolutely. So, but yep, there it was right there. Good. 13, Evangeline.
13. So first, I added first I added 6 and 7. Yeah, and then I just lined it all up.
Yep.
And then common denominator is 4.
Uh-huh.
And the first number should be 2. And the second one is 0. And the last one is 1. And
Okay.
then you add them all up and you get 17 and 3/4.
Right. So again, a lot of you probably can see 2/4 in your head without rewriting. Doesn't go over. So there's my 3/4 right there. There's a 10 family, 6 and 4 plus 7, 17 and 3/4. Yep. Good. Yeah, good. 15, Dom.
Okay, where is it on the page? Oh, found it. Okay, so what did I do? Okay, so first I rewrote everything with the common denominator,
Yep.
which is 8.
Yep.
So then, 2 8s, and then that one works. And then, I added all the fraction parts up, which is 7/8.
Yep.
Then I added the whole numbers, which is 19.
Yep.
7/8.
There it is. Totally works for me. And again, my challenge to you would be, did you see this in your head? And if you had to write a little, that's okay. But to not, really, like we went back to our first day here where we rewrote and wrote it this way. Could you see 1/4, 1/8, and 1/2 all in your head equals 7/8 without moving a pencil? If you could, awesome. If you can't, again, I'm not saying that's bad, but you can see how this can save time though, right? What we can get out of this, if you can see some of this in your head, you see the benefits? This is where you all nod your head at me. Go, yes, we see, Mr. Miller. All right, 17, Jackson.
Okay. So first I okay, sorry. First add 2 and 3/5 plus 1 and 1/2, and the common denominator is 10. So 2 times 5 is 10, and then 1 times 5 is 5. So 3, and then 2 times 5, and 2 times 3, you get 6 tenths. So 6 tenths plus, 5 tenths equals 11 tenths. I got too messy on my paper, so I read it. So I'm doing and then plus, and then you make that a mixed number, so you get 1 1/10.
I was at 2 11/10,
Huh? 11/10 equals 1 1.
right?
And then plus 1 1/2 equals 2 and
This was 2 3/5, so you should have 3 1/10 over here.
I'm sorry, I can't read my stuff. 'Cause
Well, let me just, not that you're not doing great. Anybody else? There's a better way here. This is getting complex. Damien,
Okay.
You already
so
did
you
one.
could add 1/2 to 1 1/2.
right,
You get 2.
right
And then you
here.
add 2 to 2 3/5, and you get 4 3/5.
There's
I
my
got
answer.
that, I
right
got that, but I got that. Not that way.
And that's fine. I'm not, this isn't meant to make anybody feel bad. It's really not. But, right, commutative property. As long as I'm just doing adding, I can add things in any order I want. These brackets here are just throwing me off the scent here because it's add. 3 plus 2 plus 1 is the same as 1 plus 2 plus 3, which is the same as 2 plus 3 plus 1. So I can add things in any order I want. And looking to add these first, 1/2 plus 1 1/2 is 2. 2 plus 2 3/5 is 4 3/5. So if you got 4 3/5, I love how you did it. Jackson, you were fine. It was just getting a little complex here, your path. So, again, good. Damien, good. Dom, did you see it that way too?
Yeah.
Right? Okay. Did others see it this, or were you doing it the first way he was doing it?
I did it with the brackets, but then I was like, there's no point.
Yeah, and that's cool. You know, just all about showing you what you can do here, if you can find these things. But I guarantee you, there's benefits to you, and you've started to see some of the benefits. And if you can find some of this stuff, boy, it sure makes your work a lot faster and easier, doesn't it? Yeah. So, you'll get to keep practicing. Don't think anything of it. You guys did good. Okay, so anyway, we'll check the homework tomorrow. Only 18 problems. There we go.